how to compare thermal systems based on performance. Welcome to Building Knowledge 101. In this video, we will compare thermal systems based on their performance and analyze results. So here's a non-thermal frame. I want to show you how U factors play in now to your selection of your thermal breaks. Here's a non-thermal frame. If I take that frame and put an insulated glass unit that has a center glass U factor of 0.28 and test the two together, I come up with a system U factor of 0.47. So that won't pass in either of those climate zones, because if you remember climate zone 3, we had to have a maximum of 0.46. So we can't use this. We need to look at other options. So here you can see a thermally improved frame. This is your mullion on the interior and your cover on the outside. And those are joined together with a polymer clip. So you can see the three components: extrusion on the inside, cover on the outside, and polymer clip. So this is a non-composite frame. These are not joined together, mechanically attached. They hold the pieces together with a clip here, but they're not bonded together. So this is a non-composite, thermally improved system. When I put that same insulated glass unit that has a center glass U factor of 0.28 into this frame, the resulting U factor is 0.45. So you can see we've shown improvement by going from a non-thermal frame to a thermally improved. And now with a 0.45, we meet the maximum U factor requirements for zone 3, but not for zone 6. So let's look at some other options. This is thermally broken as opposed to thermally improved. It's thermally broken. We've got a pour into bridge thermal break. So now we've got thermally broken system. Let's put the same piece of glass into it that has a center glass U factor of 0.28, and that has improved our system performance down to 0.39. So in zone 3, we needed 0.46, so we've shown considerable improvement over the maximum U factor required for zone 3. But for zone 6, we need 0.36, so we're not quite there yet. So let's take a look at some other options available to us. We know that the greater the separation of metal from the interior to the exterior, the better the thermal performance. So that last system I showed you was thermally broken, had a 1/4 inch thermal separation. So here is a similar system using 2 pour into bridge thermal breaks, or dual pour into bridge. So now we've increased the separation from the interior here to the exterior here. We've increased that separation, improving the thermal performance of the system. So if I take that same piece of glass, the insulated glass unit with 0.28, put it into the dual thermal break, now we have a system with a U factor of 0.36. So now we exceed the base requirements for zone 3, and we make the minimum requirements or the maximum U factor requirements for zone 6. If you want to continue to improve the thermal performance, you can improve the performance of the glass now, and that will improve the overall system. So those are storefront examples. You see the same thing with curtain wall systems. If you're working on a project and you have curtain wall, here you can see a non-composite curtain wall. We've got mullions on the inside, extrusion on the inside, cover on the outside, and then a polymer clip or isolator that's separating those two metal components from each other, so you don't have a direct pass. So this is thermally improved. And if I take that same line of glass with center glass U factor of 0.28 into this system, we now have a system U factor of 0.49. So we still need more improvement. We need to do better than that. Here's a thermally broken curtain wall. This one incorporates a 1/4 inch EPDM rubber gasket that runs the entire, all the way around the perimeter of the frame, so the heads, jambs, horizontal sills all the way through. So it's separating the mullion on the inside from the pressure plate on the outside. So this is thermally broken. If we put our glass with center glass U factor 0.28 into here, now we've improved our performance to 0.45. So in climate zone 3, we're good, but in climate zone 6, we still need to look for improved performance. So here's an SSG curtain wall system. It's structural silicone glazing. Now you might not think of an SSG system as a thermal strategy, but it really is. If you look at the section cut, there is no metal going through this area. Where your 2 insulated glass units come together, you've got a weather seal in this area, backer rod here, but there's no metal penetrating through this. So this is actually quite a good strategy for thermal improvement. If I put our same line of glass into here, then we have dropped the system performance to 0.39. So for climate zone 3, we're showing great improvement. We're still not where we need to be for climate zone 6 though. So this is a polyamide insert in a curtain wall. This is a polymer piece that's combining 2 extrusions together, and it is crimped in place and chemically adhered. So this is bonded together. So you've got your interior extrusion, exterior extrusion, the polyamide shape popping between them. Polyamide has really been growing in popularity. Most manufacturers are offering different types of polyamide inserts. Here's a curtain wall where a polyamide neck piece has replaced 3/4 of an inch of aluminum in the curtain wall. So you can see in this area where there normally would be aluminum, and here is your 1/4 inch EPDM gasket here. This section has been replaced with a polyamide insert. So now you have a full 1 inch of separation from the metal on the exterior from the metal of the interior. And now most curtain wall manufacturers and window manufacturers are offering triple glazed options. So we're really seeing a lot of increased demand for thermal performance, driving most manufacturers to present the option of going from double glazing to triple glazing. So you can see that option is listed here. Let me just point out one other thing about polyamide. We're finding with windows, polyamide is excellent because we can replace larger components of the aluminum frame with polyamide. With windows, it's great. You can see how these frame sections, which are around the perimeter, aluminum has been removed from the center section and polyamide inserted in here instead of aluminum. Since this is typically windows are punched openings, these are jambs. We're not worried that much about structural performance of wind load because this is going to be anchored to the surrounding condition quite frequently. So we're not worried about structural performance, but you can see how this is designed to have chambers in here to cut down on convection. And in this critical area in the center, where we have the thermal break and the insulated glass units, we're able to insert polyamide in here, replacing it with aluminum, increasing the separation of metal on the outside from metal on the inside. So polyamide has really grown in popularity. So now I'm back to our curtain wall illustration, and you can see down here I've taken a triple glazed curtain wall system with a polyamide insert in the neck and put in a lighted glass. It has a center glass G factor of 0.16, and we've dropped our system performance down to 0.28. So great improvement there. So you can see here from this illustration that as an architect or designer, based on what the energy codes are for your project location, you have options that you can choose from, different thermal breaks that incrementally improve the thermal performance of the system. Once you meet the energy code requirements based on your location, you can continue to improve the performance of the overall system by changing the thermal break or changing the glass. So there's a lot of options out there for you to continue to improve the thermal performance of the system. That is all we have time for in this video. If you'd like to watch more of our 101 video series, subscribe to our YouTube channel, Kawneer Company, Inc.